Happy Monday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, just verifying that the recording is going there. So now, here we go. Today we're going to take a look at section 10.2, part 1. It deals with something called the quadratic formula. And what we're going to do is I'm going to go through the process of where this formula came from. Now, the last assignment, we had the idea of the square root property and of completing the square. If we take a general quadratic equation in standard form, that is to say, ax squared plus bx plus c equals 0, and we solve this equation for x, we get what is known as the quadratic formula. Now, recall that a, b, and c stand for numbers, okay? So what I'm going to do, I'm going to complete the square. First of all, my leading coefficient is a. So I'm going to divide each term by a. This gives me x squared plus b over ax plus c over a equals 0. The next step, we're going to move the constant to the right side of the equation, which would be the c over a. So we're going to subtract c over a from both sides of the equation. This gives us x squared plus b over ax equals negative c over a. All right. Now, we're going to take the coefficient of x, which is b over a. Okay, we're going to divide it by 2, which is like b over a divided by 2, which is like b over a times the reciprocal, which is like b over 2a. So we took the coefficient of the x, divided by 2. Then we're going to square it, which is b squared over 2 squared, which is 4a squared. Okay, and we're going to add that to both sides of the equation. All right, now having done that, on the left side of the equation, I should have a perfect square that looks like this: x plus b over 2a, the quantity squared, because remember, it's this thing right here, okay, equals, on the right side of the equation, I'm going to do a little massage work, okay? I'm going to take this, I'm going to reverse the order, and I'm going to write it b squared over 4a squared minus c over a, okay? I want to combine those so they have the same common denominator. So it's going to be b squared over 4a squared equals something over 4a squared. Well, to get there, I'm going to have to multiply by 4a over 4a. So now my new numerator is going to be 4ac. So now I could write this as a single fraction, b squared minus 4ac all over 4a squared, which is going to go over here. So now I have, on the left side, I have a perfect square trinomial containing the variable. And on the right side, I have a constant, because remember, a, b, and c are all numbers. I also know that a in the denominator is not 0, because if going back here, a had been 0, this wouldn't be a second degree equation. So I know up front that a is not 0. So now what do? I take the square root of both sides of the equation, okay? I'm going to take this and recopy it on the next page. X plus b over 2a quantity squared equals b squared minus 4ac all over 4a squared. Yeah. So now I take the square root of both sides of the equation. Plus or minus. On the left side, I get x plus b over 2a. On the right side, I'm going to separate the numerator from the denominator. Okay. Again, on the left side, I've got this. On the right side, I can't separate the numerator, but the square root of 4a squared on the bottom would be 2a. Okay. Now, why can't I take the square root of b squared minus 4ac and separate b squared and minus 4ac into different terms? Because they are terms. They have to be factors to pull them apart. So I'm stuck. In other words, this can't be simplified any further. Next move is going to be to subtract b over 2a from both sides. So now I've got x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. But they have the same denominator, so I can put them together and I get this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, ladies and gentlemen, is the quadratic formula. What good is it? What do we use it for? Well, let's go back to chapter 6. And we factored to solve second degree equations. Now, instead of factoring, we can use the quadratic formula. Now, in some cases, if something factors fairly easily, it would seem pointless to go to all this trouble. But the ones that are tricky to factor, we can use this formula. And when I say all this trouble, all of this and back here was just figuring out the formula. We're just going to go straight in and use the formula. Okay, so this is the quadratic formula, and it's used to solve second degree or quadratic equations. All right, I'm going to start with one that factors easily so that we can see the solutions. Let's say we've got x squared plus 5x plus 6 equals 0. And I could factor that thing, and I'd have what? Plus 3 plus 2. And then I get x is negative 3, x is negative 2, right? Okay, that's going back to chapter 6. Now, let's use the quadratic formula. It still has to be in standard form. Ax squared plus bx plus c equals 0. A is 1, b is 5, and c is 6. Kind of like when I used factoring by grouping, okay? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 6 all over 2 times 1. X equals negative 5 plus or minus the square root of 5 squared is 25 minus 4 times 1 times 6 is minus 24 all over 2. X equals negative 5 plus or minus the square root of 1 all over 2. X equals negative 5 plus or minus, well, the square root of 1 is 1 all over 2. So x equals negative 5 plus 1 over 2, which is negative 4 over 2, which is negative 2. X equals negative 5 minus 1 over 2, which is negative, whoops, got ahead of myself there, which is negative 6 over 2, or negative 3. So x equals negative 2, x equals negative 3. Now, this is an example where obviously factoring is easier. I just use this example to show that, yeah, I get the same answers, okay? But where this is going to come in handy is where we have answers that are irrational, square roots, things like that, or where we get really big numbers. It's like we don't want to have to try and factor that, or anyway, okay. So now let's go back and just practice the quadratic formula. So here we have x squared plus 3x plus 2 equals 0. we have a second degree equation that's in standard form. That is ax squared plus bx plus c equals 0. So just like if we were going to factor it, but we're not. So now a is 1, b is 3, and c is 2. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplifying, x equals negative 3 plus or minus the square root of 9 minus 8, because minus 4 times 1 is minus 4 times 2 is minus 8, all over 2. X equals negative 3 plus or minus the square root of 1, all over 2. X equals negative 3 plus or minus, well, the square root of 1 is 1, all over 2. So x is negative 3 plus 1 over 2, which is negative 2 over 2, or negative 1. X is negative 3 minus 1 over 2, which is negative 4 over 2, which is negative 2. So x equals negative 1, and x equals negative 2. All right, let's take a look at this example. X squared minus 18x plus 81 equals 0. This is a quadratic or second degree equation. It's in standard form. A is 1, b is negative 18, and c is 81. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to want to have the quadratic formula memorized, especially in case if you're ever on Jeopardy. You never know what they'll ask. Anyway, x is 18 plus or minus the square root of, let's see, negative 18 times negative 18. I think that's 324. And it is 324 minus 4 times 1 times 81 is minus 324 all over 2. X equals 18 plus or minus the square root of 0 all over 2. X equals 18 plus or minus the square root of 0 is 0 all over 2. Well, 18 plus 0 is 18, and 18 minus 0 is 18. So basically, we just get x equals 9, and this is what we call a repeated, let's see, they use solution, repeated solution. I was going to say repeated root, but we don't call them roots till we get to pre-calc. Anyway, so it's a repeated solution. There's two solutions, but they're both 9. For instance, if we were to factor this thing, it would look like this. So we get x equals 9 as our solutions. Okay. Let's take a look at this one. 6x squared minus x minus 1 equals 0. Again, we have a quadratic equation in standard form. A is 6, b is negative 1, and c is negative 1. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals the opposite of negative 1 would be positive 1, plus or minus negative 1, the quantity squared is 1. Minus 4 times 6 is negative 24 times negative 1 would be plus 24 all over 12. X equals 1 plus or minus the square root of 25 all over 12. X equals 1 plus or minus 5 over 12. X equals 1 plus 5 over 12, which is 6 over 12, or 1/2. X equals 1 minus 5 over 12, which is negative 4/12, or negative 1/3. So x equals 1/2, and x equals negative 1/3. Again, if we factored this, we'd come up with the same results. Now, let's take a look at one that doesn't factor. T squared equals t plus 4. I'm not going to go through the steps because I would fail if I tried to factor it using rational numbers. But I can solve it using the quadratic formula. I'm going to subtract t and subtract 4 from both sides of the equation to put this quadratic equation in standard form. So now a equals 1, b equals -1, and c equals -4. So t equals -b plus or minus the square root of b squared minus 4ac all over 2a. Notice I said t equals because I'm not solving for x, I'm solving for t. T equals 1 plus or minus the square root of -1, the quantity squared is 1, minus 4 times 1 is minus 4 times minus 4 is plus 16 all over 2. T equals 1 plus or minus the square root of 17 over 2. So t equals 1 plus the square root of 17 over 2. T equals 1 minus the square root of 17 all over 2. So those are the two exact answers. Now we're going to go back and find approximate answers rounding to the nearest hundredth. So in my calculator, I'm going to put a left-hand parentheses, 1 plus the square root of 17. That's going to be in a set of parentheses. Then I'm going to close up the entire numerator divided by 2. So parentheses, 1 plus second square root of 17, close up the square root, close up the whole thing divided by 2, and I'm getting 2.5615528813. Rounding to the nearest hundredth, that would be the second decimal place to the right. The 1 would round down, so I'm going to get 2.56 as my first answer. Now, second one, 1 minus the square root of 17 divided by 2, we get -1.5615528813. So that's going to be what? -1.56. So my two answers here are, oops, let's see here. Here are my two exact answers. And then here are the two decimal answers. Okay. Any questions there? All right, let's look at some things we could do to simplify our quadratic equations before we plug them into the quadratic formula. Because if we have things like fractions or decimals or really huge numbers, we might want to try and make them easier to deal with before we plug them in. So first example, let's say I've got this, -5x squared plus 9x minus 2 equals 0. Well, in this case, a is negative. Recall back when we were factoring in chapter 6 that I emphasized it was easier to factor if your leading coefficient was positive. Same thing here, because your quadratic formula is all over 2a. So it'd be nice to be dividing by a positive number rather than a negative number. So what can I do to make this have a positive coefficient? Well, I suppose I could move everything to the other side, but the other thing I could do is just multiply both sides by -1. So I get 5x squared minus 9x plus 2 equals 0. And then from there, a is +5, b is -9, c is +2. Okay, so you can get rid of a negative coefficient by multiplying both sides by a -1. Any questions on that? All right, here's another example. Let's say I've got decimals. 1.6t squared plus 2.4t minus 0.9 equals 0. Well, I've got decimals. In this case, they all have one decimal place to the right of the decimal point. So let's multiply both sides by 10. I get 16t squared plus 24t minus 9 equals 0. And now A is 16, B is 24, C is negative 9. And I could plug those into the quadratic formula. Again, I could still use the originals. I could use 1.62.4 and negative 0.9, but it's just nicer to not have to deal with those. All right, let's say I've got this situation. 1/8 x squared plus 1/2 x minus 3/4 equals 0. This is a quadratic equation. It's in standard form. A is 1/8, B is 1/2, and C is negative 3/4. How about we come in and we multiply both sides by the least common denominator, and we get x squared plus 4x minus 6 equals 0. Okay. So now A is 1, B is 4, C is negative 6. All right. And finally, let's say you've got something like this, 33y squared plus 99y minus 66 equals 0. Well, the first three terms all share a common factor of 33. So we could either factor out a 33 or we could just divide both sides by 33 and we get y squared plus 3y minus 2 equals 0. So now A is 1, B is 3, and C is negative 2. So those are some ways we can go through and clean up our equations before we plug the numbers into the quadratic formula. Okay, so now back to some examples. Let's say I've got this. X squared equals negative 5/4 x plus 3/2. It says solve each equation, approximate the solutions to the nearest hundredth when appropriate. So if we get radicals in our answers, that's when we'll go to the decimal approximation. Okay, I'm going to put this thing in standard form. So I'm going to add 5/4 x to both sides. I'm going to subtract 3/2 from both sides. So I'm going to get x squared plus 5/4 x minus 3/2 equals 0. I'd like to get rid of the fractions. So I'm going to multiply both sides by the least common denominator, which is a 4. So I've got 4x squared plus 4 times 5/4 would be 5x minus 4 times 3/2 would be 6 equals 0. Okay with that? So now A is 4, B is 5, and C is negative 6. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 5 plus or minus the square root of 25 plus 96. Negative times negative is positive. 4 times 4 is 16, times 6 is 96, all over 8. X equals negative 5 plus or minus the square root of 121, all over 8. The square root of 121 is 11, so we get plus or minus 11. X is negative 5 plus 11 over 8, which is 6 over 8, or 3/4. X is negative 5 minus 11 over 8, which is negative 16 over 8, which is negative 2. So X equals 3/4, X equals negative 2. And we don't need to use a decimal approximation because those are nice rational answers. Questions there? All right. Let's take a look at this one. 3x squared minus 9x minus 2 equals 0. This is a quadratic equation in standard form. There's no decimals or fractions to get rid of. The leading coefficient's positive. I can't factor out anything, so let's just go for it. A is 3, B is -9, C is -2. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals 9 plus or minus the square root of 81 plus 24 all over 6. X equals 9 plus or minus the square root of 105 all over 6. Okay. Now, 105, I could factor a 5 out of it, 21, but I can't simplify that any. So my two exact answers are X equals 9 plus the square root of 105 over 6, and X equals 9 minus the square root of 105 over 6. Going to the calculator, because this one I'm going to approximate. So parentheses 9 plus second square root 105, close up the radical, close up the whole thing divided by 6, and I get 3.207. It goes on, but it said to round to the nearest hundredth. So the zero's in the hundredth spot, the 7 would round up, so we're going to get 3.21. And then the minus, we get negative 0.207. So the 7 again would round up, negative 0.21. So these are the exact answers, and these are the decimal equivalents. Again, in WebAssign, you can't use the plus minus notation for your answers. You have to enter them separately and separated by a comma, and make sure that comma is outside of the radical. Okay. Let's see here. How about this one? 900x squared minus 8,100x equals 1,800. So I'm going to get it in standard form by subtracting 1,800 from both sides of the equation. I believe I can factor out or divide out a 900. So I get x squared minus 9x minus 2 equals 0. Now, let's say that you don't do that. Let's say you just leave the numbers huge. You can still get the answer. You're just going to have to do a lot of reducing down at the end there. Okay. A is 1, B is -9, C is -2, X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. The place that students make the most mistakes is right in here with those negative signs. So really be careful, watch those signs. X equals 9 plus or minus the square root of 81 plus what, 8, because we've got not minus 4 times 1 times -2 is positive 8 all over 2. X equals 9 plus or minus the square root of 89 all over 2. Okay. 89 is prime, so I can't do anything there. So my two exact solutions are going to be 9 plus the square root of 89 all over 2. 9 minus the square root of 89 all over 2. And now I'm going to go to decimal approximations, rounding off to the nearest hundredth. Parentheses 9 plus the square root of 89, close it up, close up the whole thing divided by 2. 9.216, which is going to be 9.22. And then the second one is going to be negative 0.216 or negative 0.22. So here are your exact solutions. Here are your decimal approximations to the nearest hundredth. All righty. Oh, wait a minute. Yeah, there's one more I want to do. Okay, let's say you've got this. X times x minus 27 equals 280. So this thing's a long ways from standard form. So we're going to go x squared minus 27x equals 280. Then we're going to subtract 280. So we're going to get x squared minus 27x minus 280 equals 0. Now we'll go from there. A is 1, B is negative 27, and C is negative 280. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. The point is, you've got to get it to here before you use the quadratic formula. X equals 27 plus or minus the square root of, let's see, 27 squared is 729. Minus 4 times 1 is negative 4 times negative 280 is positive 1120 all over 2. X is 27 plus or minus the square root of, let's see, 1120 plus 729, 1849 all over 2. Let's see if 1849 is a perfect square. It is. It's 43. Nice. So x equals 27 plus 43 over 2, which is 70 over 2 or 35. X equals 27 minus 43 over 2, which is negative 16 over 2. Is that right? Yeah, which is negative 8. So x is 35, x is negative 8. So tomorrow we'll come back and we'll look at applications or story problems involving the quadratic formula. That'll wrap up section 10.2. Then on Wednesday, we'll go on to 10.4. And Thursday, Veterans Day, there's no school, no classes, no Zoom meetings, nothing, but then we'll come back again on Friday. Anyway, I'll be back today at 1:15. Should you have any questions? Otherwise, let me stop the recording.